Phase 3, Commissioning and Integration. Before feeding real signal into the DAS, engineers want to make sure that the DAS will work as expected. That means they check all the signal paths within the electronics and cables that make sure they're working as expected. This is ensured in the commissioning process. In this video, we'll talk about high-level steps of commissioning and integration. Initial configuration. This confirms visibility of all devices as well as connectivity between them. Integrator makes sure that all the devices connected to the head end are visible from data controller. The data controller allows you to see all the connected devices. We do CW or continuous wave test to check all signal paths. CW is a blank signal at a particular frequency. We already checked various qualities of the cable path through sweep, PIM, OTDR, and optical loss tests during the construction. By doing these, we made sure all the cables are ready to transmit signal properly. We need to check signal paths from head end to remotes and all the way to the antennas. Remotes are connected to the head end via fiber and connected to antennas via coaxial cable. So if we feed continuous wave signal into the head end and then measure signal at each electronics on the way to the antennas, we are essentially checking the full signal paths. Now we compare that measured output against the calculated value to determine if the system is working as expected or not. How can we get all the calculated values? We can manually calculate it, but engineers usually can get all the calculated values from IBwave. Checking for multiple frequencies. If you're building a multi-carrier DAS, engineers will also have to check these paths in multiple frequencies because electronics may have cards within them dedicated to particular frequencies. Checking downlink and uplink. Engineers also have to check downlink and uplink paths. Now, in this slide, I will show you through a block diagram the typical test points or collection or locations, test points or locations during CW test. Here is a block diagram of DAS 2.0 system you have seen before. For downlink, CW signal source output is fed into RIU or RF interface unit. Note that for uplink, signal source output will be fed into antennas or remotes, or basically will start in the opposite end of the DAS. These are all typical test points where engineers will measure the power of RF signal in different frequencies. When we check at different locations and in different frequencies and in downlink and uplink paths, engineers end up with thousands of data. As we mentioned in the last slide, all of these measured data is compared against the calculated value from IBwave program. If the DAS is built right, these calculated versus measured values should be very close. One more thing, tools used for CW tests are CW signal source to feed signal, often called SIGGEN or signal generator. And to measure output, we use power meter or spectrum analyzer, also known as SPEC-A by the technicians and engineers. Integration or adding carrier signal source. Once the engineers complete all the steps described in the last two slides, your DAS is ready to accept carrier signal, which means Sprint or AT&T or Verizon can now join the DAS. We are assuming at this point that the intended carriers have installed and turned up their signal source at the site. This installation of carrier signal source can be a whole project by itself, and we'll discuss a little more in the project management section. Noise optimization. Too much noise can drown the real signal. Noise can be a big problem if not properly optimized. When we talk about noise, we are mainly talking about uplink noise, the noise that is going back to the signal source. Sometimes this noise optimization can be done in two phases. Phase number one, which is first phase noise optimization. This noise optimization happens before the carriers connect their signal source. DAS is optimized by decreasing the noise generated by adding all the DAS electronics. Phase 2, which is after adding signal source, is the noise optimization done after the DAS engineers will have to after adding the signal source. DAS engineers will have to do this noise optimization separately with each carrier. At this point, the carriers can start collecting signal data to make sure DAS is working as expected, which is part of the acceptance and testing procedure or ATP process.